Hi all, this is Surya, working Dr.SNS Rajalakshmi College of Arts and Science, Department of Computer Science Full Stack Web Development. Today we are going to see about operating system process synchronization. Table of content. What is a process synchronization and why it is needed? Critical section problem. Peterson solution, synchronization hardware, semaphores, application of semaphores, classical problem of synchronization, synchronization examples, that is monitor and automatic transaction. Here, what is a process synchronization? Several processes run in an operating system. Some of them share resources due to which problem like data inconsistency may arise. For example, one process changing the data in a memory location where another process is trying to read the data from the same memory location. It is possible that the data read by the second process will be erroneous, and here process asynchronization produces consumer process, that is bounded buffer problem, to ensure that the product should not take add data when the buffer is full and consume should not take in data when the buffer is empty. Four buffer process is there: process A, consumer, process B, and here the solution produces consumer problem using semaphores, that is controlling access multiple process to common resource containing systems such as multiple programming system, and using monitor. Here monitor is synchronization consists of construct that allows threads to have both mutual execution and wait and certain condition to be become true. Automatic transaction, that is single thread, that is with all the time relation remains correct when their values wrapped around the inter overflow. Race condition, that is T5 happened before T4. Critical section problem, a section of code common to n corporation process in which the process may be assessing common variable. Critical section environment contains entry section code requesting entry into the critical section. Critical section code with only one process can execute at any one time. Exit section, that is critical section must enforce all these three following rules: mutual execution, progress, bond, and wait. No more than one process can execute in a critical section at one time. Progress, no one or more critical section, that is process nor the remainder session. Bounded wait, here the critical section problem, critical section exit section, remainder section. But Peterson solution, to handle the problem with the critical section CS, Peterson gave an algorithm, that is, suppose there is an process P1, P2, it ends to Pn. Then some points are needed to be critical section. A flag carries a size n, and there is another variable called turn, which indicate the process number. Currently enters into the CS and turn to the another number with ready process 10. Synchronization hardware. Problem to critical section also solved by hardware. Uniprocess system disable interrupts while a process PI is used by CS, and another process trying to enter CS cannot enter, is locked. And advanced approach of automatic instruction. Mutex locks. Synchronization hardware solution easy to implement for everyone. Mutex locks was introduced. In this approach, entry section of code, a lock is required to critical resource and critical section. Exit section, that locks is released. As a resource is locked, the process execution is critical section. Hence, process can access with the team. Thank you all.